Hello and welcome back. Today we'll talk about one of the important topics in JavaScript. It's about call stack, memory heaps, and execution context. We'll see what all of this. Before we dive into the video, please consider subscribing and sharing the content with your friends. If you like the content, please do give me a thumbs up. Before we start with the topic, I want to go through a data structure called stack. Stack is a data structure which works on the last in, first out principle. It works on two fundamental operations. One is push and the one is pop. When you call push, it enters data into the stack. When you pop, it removes the most recently added elements out of the stack. And at any given time, the topmost element of the stack is called the top. You either push an element on the top and the top is updated to the newly pushed element, or when you perform the pop operation, it removes an item which is on the top. In one of our earlier videos, we discussed JavaScript engine and runtime. Memory heap and call stack are the part of JavaScript runtime environment. Now, let us look at what call stack does and what memory heap does when a program executes. I'm just reminding you that memory heap stores all the data required for the program execution. On the other hand, all the created execution context will be stored on the call stack, informing us where we are in the program execution. Now, let's look at what an execution context is. Execution context is an environment in which the JavaScript code is executed. By environment, I mean the value of this variables, objects, and functions JavaScript code has access to at a particular time. There are three different types of execution context in JavaScript. The very first one is global execution context. This is the default execution context in which JavaScript code starts its execution when the file first loads into the browser. It executes all of the global code. What I mean by that is it contains all the code which is not a part of any function or objects. On the screen, I've tried to show you how the execution context looks. The very first stack is global execution context stack, which contains all the global execution context related code. Feel free to pause the video and try and relate whatever we discussed so far. Now, let's talk about functional execution context. A functional execution context is defined as the execution context which is created by the JavaScript engine when it finds any function call. What do I mean by that is, as soon as a JavaScript engine finds any function name with a pair of parentheses in front of it, it will create a functional execution context. Now, does that mean it requires 100 functional execution contexts if we have 100 functions? Let us see about it. It turns out that it's a false statement. When a function is called, a functional execution context is created. Once all the code in the function is executed, the stack is popped off, and the next function is called, and a new context is created for execution. Now, you might wonder, where do we need more than two stacks for the execution context? Let's look at an example. If you have a program which is written like what is shown in the video, if a function is called within function, it is called nested functions. What happens here is when a function tries to execute, it will create its own execution context. Within the created execution context, it will have all the code written within the function block, be it a variable or a new function. So when it sees a new function within its block, it will create another execution context for the new function. That is what's happening here. When we call function 1, it is gone into the function 1 block and checked for another function. So when it found the function 2, it created another execution context. And later, function 2 has function 3. Again, another execution context is created. Once it executes all the code in the function, then the stack will be popped off. That is what happens with all the three functions. Once the whole program is done, even the global execution context is popped off. One another important thing is a functional execution context will have access to global variables. However, Global execution context will not have any access to the variables declared within the function. We will discuss about scopes in later videos. Now let us watch this in action in Chrome browser. To do this, open your console. There is a tab called Sources. Please navigate to Sources. Once you're in the Source tab, you'll see something similar to shown in the video. Create a new snippet by clicking on the right arrow. So once you have a new snippet, you can start typing the code in that. Before we start coding, I want you to have a look at other features on the browser. If you see on the right side of your window, you have something called stack, scope, breakpoints, etc. So in this video, we'll be only concentrating on the call stack. I'll be demonstrating call stack and execution context with two simple functions, where I'll call a function within another one. So there is a function which says print output and another function called add three numbers. In add three numbers, I'll just add three numbers and call it in print output function. Before you call the function, just make sure that you add a debugger so that you can navigate step by step. So once I add a debugger and call the function, I'll execute the program. Now I've called print output function. Let me add a debugger. Yeah, I've just added a debugger. Now I'll try and run this program. I want you to notice the call stack as soon as I run the program. You now see an anonymous execution context on the call stack. This is supposed to be a global execution context. It is in browser environment, so we are getting it as anonymous. Let's see what is an anonymous execution context. I'll be calling this keyword. I mentioned earlier in this video that there will be something called this and the global object. In the browser, the global object is window, so it has both of it. Let's continue with our execution and invoke the print output function. I have invoked the function by clicking on the down arrow symbol on the console. So now you see that the print output has been pushed onto the stack. So now let's see what happens when I call addition of three numbers. So now it has called the addition of three numbers and another functional execution context has been pushed onto the call stack. So hope this shows how a call stack is populated. Now I'll just continue with my execution. Once the addition of three number function completes all the tasks within the function, the stack is popped out. Similarly, once the print output function is executed, even the print output functional execution context is popped off. So finally, once execution is complete, even the global execution context will be popped off. I just wanted to demonstrate another example where we have multiple functions where the functions do not call each other. So in this piece of code, I have created two functions and I've added a debugger and called both of them. So when I call the addition of three number function, addition of three number is called onto the stack. Once it executes addition of three numbers, it will be popped out of the stack. Then a new function is called, that is print output. So now we are executing the print output, and once the print output is done, it is popped out of the stack. So that is how the stack will be populated and cleared during the execution. We are almost at an end of this video. I just wanted to screenshot this and show you how the functional execution context was called on top of the global execution context when a function is called within another function. I really want you guys to understand this clearly because this has a greater purpose than just understanding. When we dig deeper into the other major concepts like scopes, hoisting, closures, and functional programming, this has great role to play. I really hope you understood everything. If not, please go through the videos couple of times. And that's it for this video. Hope you like the content. If you like the content, please give me a thumbs up and do not forget to subscribe to my channel. Thank you.